Phenenthrene is an isomer of anthracene. It may be obtained along with anthracene from the green oil fraction of coal tar. On cooling this fraction, we get solid mass which contain phenenthrene, anthracene, and carbazole. Treatment of this with solvent naphtha dissolves phenenthrene. Evaporation of the solution yields crude phenenthrene, which may be purified by recrystallization of the precate from ethanol. Nomenclature. This is structure of phenenthrene. It exists in two forms which are given here. And numbering should be start from the very first carbon atom 1, 2, 3, 4, and then numbering given to third ring and then second ring 5, 6, 7, 8, 9, 10. It should be clockwise. Same here. Phenenthrene molecular formula of phenenthrene is C14H10 and two structures are given here. Mono substitutions 5 isomers are possible for phenenthrene and di substitutions 25 isomers are possible for phenenthrene. Structure of phenenthrene. Like anthracene, phenenthrene is a planar molecule. All 14 carbon atoms which are present in phenenthrene molecules are sp2 hybridized when sp2 orbitals of carbon atom overlap with other carbon atom and with s orbital of hydrogen atom to form carbon-carbon sigma bond and carbon-hydrogen sigma bonds. Each carbon atom present in the hydrogen atom also possesses an unshared p orbital, and the lateral overlap of these p orbitals possess a pi molecular orbital containing 10 electrons. Phenenthrene shows aromatic properties because the resulting pi molecular orbital satisfy the Huckel's role 4n plus 2 rules. And this is common shorthand representation of phenenthrene molecule. It also considered to be hybrid of following 5 structure which are given on next page. These are 5 resonating structure of phenenthrene molecule. C9 and C10 bond to have more double bond characters. The resonance energy of phenenthrene is 92 kilocalorie per mole. For benzene, it's 36 kilocalorie per mole. Synthesis of phenenthrene. There are two methods by which phenenthrene can be prepared. Like first, Howard method. In this reaction, naphthalene treated with succinic anhydride in presence of AlCl3, and it will form this compound which undergoes reduction process, and then it reacts with concentrated sulfuric acid and again undergoes reduction process with zinc mercury HCl in presence of palladium catalyst. By heating, it will ultimately form phenenthrene molecule. Next, Bosch synthesis. In this reaction, nitrobenzaldehyde treated with sodium phenyl benzoate in presence of acetic anhydride to form a compound which undergoes reduction process. Then it react with sodium nitrite and sulfuric acid and undergoes in presence of copper catalyst. Finally, it will form phenenthrene molecule. Properties of phenenthrene. Physical properties. It is a colorless solid. Melting point of the compound is 100 degrees centigrade. It is insoluble in water but dissolved readily in ethanol, benzene, and ether. Phenenthrene gives blue fluorescence in benzene solution. Chemical properties. Phenenthrene undergoes oxidation, addition, and electrophilic substitution reactions. As with phenenthrene, these reactions preferentially occur at the C9 and C10 positions. Some of the important reactions of phenenthrene are given below. First reaction with halogens. Phenenthrene react with chlorine in carbon tetrachloride room temperature to give 9,10 dichloro 9,10 dihydrophenanthrene. An addition product on heating this loses a molecule of hydrogen chloride to yield 9-chlorophenanthrene, a substitution product. In this reaction, phenanthrene react with chlorine in presence of carbon tetrachloride to form 9,10 dichloro 9,10 dihydrophenanthrene, which by heating ultimately gives 9-chlorophenanthrene. Next, Friedel-Crafts acylation. Phenenthrene undergoes acylation with acetyl chloride in the presence of aluminium chloride at 0 degree centigrade temperature to gives 9-acetylphenanthrene. Next, nitration. Phenenthrene undergoes nitration with concentrated nitric acid and sulfuric acid to yield 9-nitrophenanthrene. Next, sulfonation. Phenenthrene reacts with concentrated sulfuric acid at 200 degrees centigrade temperature to give a mixture of 2-phenanthrene sulfonic acid and 3-phenanthrene sulfonic acid. Next, reduction. Phenenthrene undergoes reduction with sodium and isopentanol to form 9,10 dihydrophenanthrene. As you can see in the reaction which is given here. Next, oxidation. Phenenthrene undergoes oxidation with potassium dichromate and sulfuric acid or chromium trioxide in acetic acid to form 9,10 phenanthraquinone. At the melting point of the compound is 206 degrees centigrade. Further oxidation of this with hydrogen peroxide in acetic acid gives diphenic acid.
Next, medicinal uses. Phenenthrene is used to make dyes, plastic, and pesticides, explosive, and drugs. It has also been used to make bile acid, cholesterol, and steroids.